Welcome back, geometry students. It's kind of a sad day because we're finishing up the unit about what goes on inside triangles. It's our last lesson. We're going to talk about inequalities in two triangles. So in this particular lesson, we're going to learn about the Hinge Theorem and its converse. And we're going to use it. So that's what we're going to learn. So let's talk about the Hinge Theorem, okay? Okay. So here's our notes, right? Some good stuff to copy. It's called the Hinge Theorem. It works when you're dealing with two triangles. So notice what's happening whenever the Hinge Theorem applies. You're dealing with two different triangles. Now, in each case where the Hinge Theorem works, you're dealing with two sides being congruent. Okay, so in the two triangles, we have two congruent sides. In the two triangles, two congruent sides. The Hinge Theorem itself talks about, well, if the included angles aren't congruent, then we're talking about then sides. So if angles, then sides. That's the Hinge Theorem. So basically, if you have two triangles with two sides congruent, the triangle that has the larger interior angle, the larger included angle, will have the larger side opposite. And if you paid any attention to the previous lesson, you should be thinking, well, yeah, true, right? Because we remember that the largest side of a triangle is opposite the largest angle. So in the two triangles, if the sides are congruent, the triangle with the larger included angle will have the longer side opposite. That is the Hinge Theorem. The converse of the Hinge Theorem is, well, if you have if the side is longer of one of the two triangles, then the included angle is longer or larger. Okay, so if sides, then angles. That's the converse. Now, again, remember, the largest angle of a triangle is opposite the largest side. Now you may be wondering, why do we call it the Hinge Theorem? Well, check it out. I drew a neat picture. That's my door. You like that? So it's like a door. Okay, you have a door with a doorway. It's the same size no matter what, and the door itself is the same size no matter what. The distance from edge to corner is going to be larger when the included angle is larger, and the distance from edge to corner will be smaller if the included angle is smaller. Okay, so I drew a picture of the door. That's why we call it the Hinge Theorem. Anyway, I just wanted to demonstrate my artistic capabilities. Let's do some examples, and then that'll wrap up the unit. So take a look at this first example about using the Hinge Theorem. Which of the following statements must be true? So we have this given diagram, and notice what's happening. We have congruent side here and congruent side here. Now, if that's the case, what we have to start doing is paying attention to the included angle. The included angle in this triangle is 70. The included angle here is 90. So we should be thinking already what is going to be larger. Okay? So this opposite side here, SK, is going to be way, way longer. Well, not way, way, but longer than this one's going to be shorter. Why? Because 90 is bigger than 70, right? 90 is greater than 70. We always know that. Okay, so if that's the case, the included angle is larger, then the side will be longer. So now what we have to do is take that understanding and make it look mathy. How in the world do we take this knowledge and apply it to one of these crazy answers? Well, we're going to do a lot of translating English into math today, and this is the first way in. So this side here is SK, right? And SK is going to be greater than this side here, OU. So that's how we say it. SK is greater than OU. Not OU, YU. What's wrong with me? Good catch, guys. YU. So SK is greater than YU, not OU, YU. Hopefully you caught that mistake. Anyway, I'll keep moving. So if that's the case, well, which one of these says that? B. Okay, so B is the correct answer. And that's how we use it. Most of this, right, especially when we deal with inequalities, is translating English into math. So let's move on. Another example. Let's use the Hinge Theorem again. So here we have another diagram. What's going on? What inequality relates ln and OQ in the figure at the right? So let's first look for ln. Here's ln, and where's OQ? Here's OQ. Now, can we use the Hinge theorem here? And the answer is yes. But why? Because 7 is congruent to 7, and 4 is congruent to 4, so we have to look at the included angles. Okay, we have to look at the included angles. Clearly, 125 is bigger than 78. That means the side opposite 125, ln, is going to be greater than the opposite of 78, OQ. And that, my friends, is an inequality. Okay? So we're just saying it's something is bigger than. By the way, I really don't mind calling this bigger than, right? Not greater than, bigger than. Bigger. So hopefully that was helpful. Next. Oh yeah, real life. Or not really. So we're going to apply the Hinge theorem to an example here. The diagram below shows the position of a swing at two different times. As the speed of the swing ride increases, the angle between the chain and AB increases. Okay, so as the ride further from A at time 1, which is here, when it was slower, or time 2, when it was faster. Okay, so what's happening here? So it's a swing ride, it's twirling, twirling, twirling. Now, the faster it goes, the higher the swing is going to go. What's interesting about this is that the distance from B to C is the same, no matter what. Distance from B to C is the same, and the distance from A to B is the same, no matter what. Okay? So what is changing? What's changing is the distance from A to C. So we have our two congruent sides. We have to pay attention to the included angle. And the question is the ride further from point A at time 1 or at time 2? Is the ride further from A? Is this distance greater at time 1 or time 2? Clearly it's going to be time 2, right? That's going to be the clear answer. So I even have a little thing down here. Since segment AB and BC are the same in both figures, okay, then the AC that's opposite the larger angle, which is in this case 2, will be further, the longest, furthest from point A. Okay, so we see how the Hinge theorem works. Logic, right? Next. Now we start talking about the converse of the Hinge theorem, and I'm going to spend some energy talking about translating English into math. So let's take a look at this diagram. We have to do some thinking. What is the range of possible values for x? Here's x, right? And we have to think what's happening here. Well, let's look at the picture. We have a side congruent to a side, and good old reflexive property congruent to itself. Okay, so yeah, we have two separate triangles with two congruent sides. So now we have to pay attention to the included angle. So we have an included angle here and an included angle here. That's not congruent, but there they are. And we have to look at what's happening opposite the included angle. Clearly, we can see that 60 is going to have to be bigger than this. Okay, so 60 is going to have to be bigger than 5x minus 20. Why? Because 15 is bigger than 10. So we already know 60 will have to be, must be, right, must be bigger than 5x minus 20. We've got to know that. Okay, so 60 must be bigger than 5x minus 20. So we have to know that. And I'll talk about something else in a second. But if we have that understanding, the rest is figuring out how do we translate English into math. First thing is this word range. What the heck? So now, how does a range work? A range is basically a value from one value to the next value. That's a range. In between here and there. That's a range, okay? So a range is from between here and there. So, as we have established, 60 must be bigger than 5x minus 20 because of the Hinge theorem, or the converse of the Hinge theorem in this case. But there's a mathy way of saying that. So here's that we need to know that there's a mathy way of saying that 60 must be bigger than 5x minus 20. Do you know what that mathy way of saying it is? With an inequality. Okay? That means 60 is bigger than 5x minus 20, or if we're looking at it this way, we'd have to look at it this way too if we're thinking of the first part. So 60 is bigger than 5x minus 20, but that's the same thing as this. It's still the same thing. Okay, so notice what's happening is the old alligator. 60 is bigger than 5x minus 20. Notice how the alligator is still eating the 60. Yum, yum, yum. And this alligator is still eating the 60. Yum, 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 yum. So either way, there's a mathy way of saying that 60 must be bigger than 5x minus 20. But wait, there's more. We're not done with thinking yet. We have to think. Check this out. Angles and triangles can't be 0, right? You got to understand, if you have an angle in a triangle that's 0, you don't have a triangle. That means angles in every triangle has to be bigger than 0. We have to understand that. This is a huge piece of logic here. So the angle in the triangle must be bigger than 0. So hopefully you understand that. If you don't, pause and rewind and make sure you visualize a triangle. The angle can't, you don't have a triangle if the angle is 0. It doesn't make any sense. So the angle has to be bigger than 0. But there's a mathy way of saying this. Now we know 60 is already greater than 0, right? Because 60 is 60. It's already bigger than 0. We don't need to worry about that. This is the thing we got to worry about. 5x minus 20 must be bigger than 0. It has to be, okay? So we need to think of a mathy way of saying that. How can we say that the 5x minus 20 is bigger than 0? You guessed it, another inequality. Okay, so 5x minus 20 also has to be bigger than 0. So we're translating English into mathematics, okay? So let's work that out. So how are we going to do this? Okay, so we have our two inequalities here. In the first inequality, we have 5x minus 20 being less than 60. So how do we solve that? Well, it's just like we solve equations. We add 20 to both sides, and then we have 5x being less than 80. So therefore, after we divide both sides by 5, x will be less than 16. Okay? So x is less than 16. Now, what about the other one we just had? All right, we just had 5x minus 20 is greater than 0. We have to solve that one too, right? So solve that too. Add 20 to both sides. 5x would be greater than 20, so x is greater than 4. Okay, so we have our values, right? We know that x is going to have to be less than 16 or bigger than 4. But let's say that, right? Let's say, use English. How would we say that? We would say that x is between 4 and 16. It's bigger than 4, right? Bigger than 4, but less than 16. So it's between 4 and 16. But there's a mathy way of saying that too. Okay, so we have to understand there's a mathy way of saying this too. Man, there's a lot of mathy ways of saying things. So how in the world would we say that x is both bigger than 4, between 4 and 16, both bigger than 4, but less than 16? Here's how. It's what's called a compound inequality. It's a compound inequality intersection. Okay? So this is called a compound inequality. Notice it's always the lower value here, the lower boundary, to the higher boundary. Okay, that's how it must always look. Okay, so it's something is less than x, which is less than something. That is saying between the smaller number and the bigger number. So in this particular case, when we solve for x, we know that x is going to be between 4 and 16. Okay, so it's going to be somewhere between 4 and 16. And that has to be that's the range of possible values, right? What's the range between 4 and 16? So this is how we read and we use mathy stuff to help us. Okay. So let's take a look at another example now. We'll work this one out. Okay. So here we go again. What is the range of possible values, right, from something to something else for x? First, let's take a look at what's going on. We have a congruent side here, congruent side here. We have a congruent side here, congruent side here. So now we have to pay attention to the included angles and then look at what's going on. Okay, so what is going on here? The included angle here is 3x plus 18. The included angle here is 90. But what's going on at the sides opposite, right? This one's 9, this one's 7. Therefore, what do we know? This angle is bigger. So this angle is not as big. That means what we're saying is that 90 must be bigger than 3x plus 18. Okay, I look at the words I'm using. I'm trying not to be so mathy, because if you can speak it, you can read it, you can do it. Okay, so 90 must be bigger than 3x plus 18. Okay, so how do we write that in mathy terms? We can say 90 is greater than 3x plus 18. Okay, but wait, there's more. Remember, the angles must be bigger than 0. That means this angle has to be bigger than 0. So we have to think, all right, well, this angle, the angle must be bigger than 0. The angle must be bigger than 0. So how would we write that in mathy terms? Well, the angle here is 3x plus 18. So we're saying 3x plus 18 must be greater than 0. Okay, so we have our two things. And now we solve for x in either one of them. Okay, so how does that work? We do our simple solution things here, right? We subtract 18 from both sides, and we find out that 72 is greater than 3x. Let me rewrite this somewhere else because you're going to need to see what's going to happen. So I'll rewrite this. So I'm going to show you. Check this out. Subtract 18 from both sides. Okay. And now what do we have? So we have 72 is greater than 3x. How do I solve for x now? Divide by 3. Okay, so divide by 3. 72 divided by 3 is 24, right? So I hope. 24 is greater than x. Well, that's interesting. That means x is smaller than 24, right? Hopefully you see that x is smaller than 24. X is smaller than 24. You have to see that. Okay, we're talking about the x values. So even though 24 is greater than x, that means x is smaller than 24. For the other inequality, we solve it just like equations. We subtract 18 from both sides. Then we have 3x is greater than negative 18. Divide both sides by 3. And now we see that x is bigger than negative 6. Okay, so x is bigger than negative 6, but it's smaller than 24. We have to know this. Okay, so we're saying x is bigger than negative 6. Okay, so hopefully you see that. We're translating math to English. So, how do we write that? How do we write that as a range? X is bigger than negative 6, but smaller than 24. And remember that compound inequality system where you have the smaller thing, right? So we have our inequality. It's x is bigger than negative 6, but smaller than 24. That is the range of possible values. Okay? So x is bigger than negative 6, but smaller than 24. That's how we write the range. Okay, isn't that neat? So you learn some mathy stuff. Remember, say it out loud first, and then you'll see the mathy ways of putting it. So let's end this on a quick quiz real fast, and we'll solidify this whole lesson. Which of the following statements must be true for these two triangles? So check out what's happening. We got 11 and 11, and 8 and 8, and the included angles are 75 here and 99 here. So what do we see? 99 is bigger than 75. Therefore, xy must be bigger than rs. Okay, so we already know xy must be bigger than rs. Which one of those says that? There it is. xy is bigger than rx. Choice D. Okay, so that's how that works. So you look for the Hinge Theorem at play, and we can work with that. So here's another one with algebra. What's going on here? Okay, in the triangles below, JK is equal to RS. So JK and RS are the same, and JL is equal to RT. JL is equal to RT. If KL is less than ST, what's the range of possible values for X? So we have our two congruent sides. 16 is bigger than 12. That means 82 is bigger than 2x minus 6. Okay, but at the same time, 2x minus 6 must be bigger than 0. Okay, so we got to remember that. So let's solve each one. First step is add 6 to both sides. So 88 is greater than 2x. Therefore, x is less than 44. Hopefully you saw what just happened. Okay, or you can look at it, okay, 44 is greater than x. Still, x is smaller than 44. X is smaller than 44. You got to be able to see how those inequalities work, right? And then down here, we add 6 to both sides, so 2x is greater than 6, so x is greater than 3. So x is bigger than 3, but less than 44. Okay, so we have worked that out. Those are the values for x. And then we run our test, D again. So both answers in this case happen to be D. Hooray for multiple choice. So that's the Hinge Theorem at play. That's inequalities in two triangles in a nutshell. And ladies and gentlemen, That is it for the entire unit. We now know everything about triangles inside and out. I hope you had fun. I love me some triangles. I'll see you in the next unit.